welcome everyone to my talk, Build a Binary. I love that some people are sitting on the floor. It's very much giving the vibe that I was hoping it was going to give. Like, can I be? Sorry, Tatiana, we're pointing it out. Well, I hope you're comfy and I hope you're feeling good and a little energized, even if we're after lunch. So I personally still feel the post-lunch lull quite a lot. And I wanted to apologize before we fully get started because my talk title is a little misleading. We're not actually going to be building a binary. We're just going to talk about it. We're all talk, no show. The reason why I called it Build a Binary, because originally when I drafted the talk idea, I was like, oh my God, like I'm gonna theme it after Build-A-Bear, it's gonna be a whole thing. And then I very quickly scrapped the idea because I've never been to Build-A-Bear. And I thought it would be really weird to start doing research for it, just like an engineer showing up in like Build-A-Bear, like nice. Like people would be quite creeped out. I kept the title. I'm also really happy to be in Folkestone again because the last time I was here, it was pretty traumatic experience because I did something that is not very British, which is not very British smarts, let's say. I went to eat on the beach. I had like fish and chips, and I really was terrifying because a seagull obviously took my fish, like immediately. And then as I was there, like screaming at the seagull, thinking like, oh my God, this is quite funny. 2 wasps came like and started getting on my chips. So I was like, no, this is one of the worst days of my life. So, but I'm happy to be here and try to redeem Folkestone. So, and also thank you all for coming to my talk. I wanted to introduce myself very briefly for those of you that don't know me, those of you that I haven't annoyed yet. My name is Anna. As you can hear from my accent, I'm not from around here. I am originally from Italy. I lived in the UK for 11 to oh no, maths. Hello. 12 years, 12, like, wow, since 2013, 11 years. And yeah, even though I dress a bit like a fortune teller, I'm a software engineer at Spotify. I work in developer experience and mobile infrastructure, which is really fun. And another thing to know about me is that I fixate on a lot of different things. At the moment, I am back in my ice hockey era, so I will try my best not to mention that again for the rest of the talk, but I cannot make promises because there's not many thoughts going on here, but like hockey is taking up quite a lot of it. But anyways, what am I here to do today? Seriously, I am here to pretty much talk to you about what's actually going on when you press the build button in Xcode, what's going on behind the scene. I'm hoping to demystify the process a little bit, explain a few things that I didn't know before I embarked on this journey. And when I say journey, it literally felt like a journey because I have fallen into more rabbit holes than I can count while I was trying to discover some of this stuff that I just didn't know before. Even if some of it probably is known to some of you, if it is, I'm sorry, I still hope you can find something interesting in here. And I hope it's full of things that maybe you didn't think about before or you didn't want to think about before, like it was my case. So yeah, pretty much it. We're gonna do this in like a bit of a chaotic way, which is my style, if you've been able to gather so far. And we're gonna follow a fun, I wrote fun on my notes, it definitely wasn't fun, a build failure that I've encountered, and see where that takes us and how many things we're gonna cover with that. Like we're gonna talk about compilers, we're gonna talk about what is an iOS binary to begin with, we're gonna mention build systems, what are build systems, alternatives to the default build system. So there's gonna be quite a lot of info, but what I did, which I hope it can be helpful, I have a QR code at the end, which you can scan and you can find like a bunch of resources that can, there's no good word in English for this. Well, you can deepen your knowledge on. Imagine there was like a perfect word that perfectly described this term because there is in Italian and it just doesn't translate. So yeah, that's gonna be at the end. I linked it on the last slide. So now let's get started without further ado because we've done quite a lot of ados. So a year and a half ago, I gave my first ever conference talk, which had like a bit of a different vibe to this one. It wasn't about Barbie. it was about Swift Playgrounds, and especially my relationship with Swift Playgrounds, how I started using it, and how, thanks to Swift Playground, I was able to stimulate my creativity, stimulate my motivation, and I really fell in love with Swift Playgrounds. But one thing I had to point out, when I talk about Swift Playgrounds during this talk, I don't mean like Xcode playground files that you may have used and you can open up from Xcode. It's like a separate app, like a standalone IDE that you can use both on your Mac and on iPad as well to just develop iOS and macOS apps. You can't test them, sorry, John. And yeah, it's a really cool app, and I really love it, and I've used it a lot, and I fell in love with it not just despite of its limitations, but because of its limitations and caveats. However, one of its caveats that I wasn't so pleased with was this one: the fact that you can use Swift Package Manager, but you can't use it with all types of Swift packages. And I found out the hard way, because at the beginning of my adventure, I had a £1 million idea, and no one's ever had one of those. So with my £1 million idea, I'm like, I know exactly what I'm gonna do. I'm gonna do it in Playgrounds to challenge myself. And I'm like, okay, I wanna use Firebase. So I tried to import the package. The package resolved on Swift Playgrounds. However, when I tried to build, it wouldn't build. And this is the error that I got, that if you can't read it, it says, the target type, Clang target, is not supported. So but this is an Italian gesture that maybe I shouldn't translate, but it just means a slight degree of annoyance that persisted for a while. And later I tell you exactly what it means. So when I had this happen to me, I was pretty annoyed, and I'm like, of course, I had my £1 million idea. I was like, I have to figure this out. So I started a very in-depth debugging, once again, effort. And this effort consisted of Googling my problem word for word and picking the first remotely applicable result, which in this case was an issue in the Firebase iOS SDK repo. People had the same problem as me, basically. And the Firebase people said, thanks for the report. I'm not going to interpret the message. I'm going to read it on a deadpan voice because I don't want to add tone to this. It turns out that Swift Playgrounds do not currently support Swift packages with Objective-C implementations. We're following up with Apple on this. Feel free to do so as well, blah, blah, blah. So when I first saw that, I was like, I had other things on my mind. I was a little bit lazy, so I didn't think to look any further into this. I was like, what can I do? They're looking into it, someone else is looking into it. Not my problem, I'm gonna use something else. But as time went on, and I had other great genius ideas, and I had other Swift packages with Objective-C implementations that I wanted to use and I couldn't use, like Swift numerics, etc. It started to bug me again, and I started to think about it a lot more. And when I say a lot more, you will see in the next, during this session, that it became a bit of an obsession. Because I was like, how is it possible that I just brushed it off like that and I haven't gone into depth with this at all? So I decided to take a little bit more of an involved approach, which means at least understanding what this error message meant. Clang target is not supported. And so I started by Clang target. What is Clang target? And it took me an embarrassingly amount of time to realize that Clang target is very simply a Swift package target, like an SPM class that it's declared. If you look in the Apple Swift Package Manager repo, you'll see it there. A target that has an implementation which is in the C family languages. I always struggle to say the right order in that, so from now on, I'm gonna say the C gang. When I say the C gang, I mean the C family of programming languages. So let's shorten to that. So yeah, it's a C gang target. And I was like, okay. So I looked into a little bit more in the repo and I tried to figure out where this message was being emitted from. I couldn't find anything. No idea, no indication, nothing that would say this isn't supported in any way, shape, or form. So I was really confused because I'm like, this error must be coming from somewhere, right? It's like it's a Swift Package Manager error. I didn't get it, but I started to think about it from a little bit more of a bird's eye view. And one thing that you should know about Swift Playgrounds is that a Swift Playground project is not a project at all. Well, it's not a project at all. It's a Swift package that has a special kind of product in it. And this product is It's called an iOS application. You actually can't use it yourself. So if you try to, actually, even if you try to search for an iOS application package product type, I'm pretty sure you will find nothing because I try to look a lot. So this special type of Swift package is still a Swift package. So what does that mean? It means that you can take it and you can open it in Xcode. So I did that because I was like, okay, maybe it builds in Xcode. And lo and behold, it did. So with the same project, well, the same package, with the Firebase dependency, it resolved and it built successfully in Xcode. However, it just gave me a warning saying like, you shouldn't do this, which I was like, okay, that's weird. Because it builds in Xcode, it doesn't build in Playgrounds. So I started to think there's something in the way that Swift Playgrounds builds behind the scene that must be different compared to Xcode, which I think it's a pretty sensible assumption. But at the time, and I will be very honest with you, I didn't really know anything about this. I'm like, I don't know, build, like it just does it. Like I'm not looking at this, it's just doing it when I press the button. I don't need to care about it. But I started to care maybe a little bit more. And one of my first thoughts, I'm like, okay, what must be different from the way that it's building things? One of my first thoughts was like, perhaps like looks like a compiler error. Maybe it's something to do with the compiler, but I didn't know much, if not anything, about the compiler. So I took a little bit of a detour into compiler land, which is like not a very fun version of Disneyland. Please don't be scared. It was fun. And I just, yeah, as I said, I didn't really know how compilers work to begin with. So the first thing I did, I tried to understand from a bird's eye view, from like just getting an overview of how compilers generally work. So I've made like this very, very simplified diagram. As I said, it's simplified and it's very generalized. So compiler nerds, if there's any of you here in this room, please do not come for me. They're very fiery. Like I tell you that much for free. So what usually happens is like you're starting with your source code, which is written in like a high-level programming language like Swift or Objective-C. And you're going at the beginning through the front end of the compiler. The compiler is definitely, like compilers are usually split between the front end and the back end. It has nothing to do with web development, obviously. It's just like a confusing naming, like we know many. We usually get those. And the first thing that kind of happens is the parsing stage. In the parsing stage, we're taking the code that we just have, and we're kind of like splitting it up into different tokens. And these tokens like keywords, operators, etc., etc. These tokens are then arranged in something called the AST, which is like the abstract syntax tree, which is like not a plant, it's a data structure. And it's in a data structure because we want to have the most optimal and performant way to go through it. And the reason why we have to go through it is because after we have it arranged in the AST, we're going to go through usually like a few stages of analysis. Analysis like syntax analysis and semantic analysis. You're familiar with these because you experience them when you write code. You're like, hey, why is this red? This is not good. Syntax analysis is to check the language makes grammatical sense. So like semicolons are where they should be for certain languages. Braces are, have open and closing matches, etc., etc. While the semantic analysis is more like, does a language make any logical sense? Like, am I using a variable before it's declared? So after that, we're left with something called the intermediate representation, which varies from compiler to compiler and from language to language, but generically, that's what you're left with. And this intermediate representation, which I just wrote IR on there, goes through like few loops and valleys of optimizations, like once again, depends which types, but to basically make it a little bit more performant and efficient in different ways. Sometimes more for CPU, etc., etc. There's like, once again, probably could do entire talks just for this bit. But what ends up happening is like after you're left with the optimized IR, then you're in the full back end of the compiler. And that's basically the code generation step where you're taking the optimized IR and you're coming out with assembly code that is designed for specific target architectures. So okay, it's a pretty involved process. And it's like, sorry, I actually need a bit of water. I had a genius idea of taking a little throat candy before I spoke, and I completely forgot until now. So please bear with me for a second. I hope it's not very loud on the recording because that is extremely off-putting. Anyways, so this is generally how compilers work. I thought it was an interesting bit of background because, as I said, I didn't know because I didn't study computer science in my undergrad at uni, so I didn't have to like suffer through this. And after I figured out and I familiarized myself, I was like, okay, what compiler does Xcode use? And the fun thing that Xcode doesn't have one compiler, it has technically three. And I say technically three because there's a doxy compiler, which I'm not going to talk about today, but the doxy compiler doesn't compile your code into like an iOS executable. It compiles your code into documentation, but it's like its standalone compiler that comes with a toolchain, which I thought was like pretty cool. Cool in my head. Anyways, the other two compilers are the Clang compiler and the Swift compiler. So first of all, Clang. Clang, which sounds like a really aggressive German swear word, is just a compiler that was originally made for the C gang, remember the C gang, family of programming languages. And it's open source, which is great because you can have a look and you can familiarize yourself quite in depth with it. Once again, could probably do entire talks just on this. And in fact, I'm pretty sure there are. And yeah, it's pretty cool because it's built on top of this LLVM, which I think probably most of you, some of you have heard about LLVM. I used to think that LLVM was a compiler itself, but it's not quite like it. LLVM is short for low-level virtual machine, and it's a virtual machine. I'm joking. It's not a virtual machine either. So it's not compiler itself. It's not a virtual machine. It's more like a collection of really modular and powerful compiler and toolchain technologies. And also they do like a lot of conferences. There's like a very active community. At one point I tried to imagine LLVM like a bit of a cult. Like they all, they all wear like red hoods shaped like dragons and sit around the fire and like throw computer pieces in the middle. They tell me it's not like that at all because that would have been extremely fun. I would have joined that cult so fast. And the stuff that I come up with sometimes, I'm sorry, folks. You're here for serious stuff. So Clang takes quite a few bits and bobs from LLVM, and that's a cool thing because it takes, first of all, the LLVM universal intermediate representation. So that's shared between a few compilers. And yeah, it's able to be used for a lot of optimization based on this IR. And what else was I going to say? Oh yeah, Clang is very renowned, well, was and is very renowned for being very performant, thanks to the bits and bobs it borrows from LLVM. And also because it has very good diagnostics, which is just fancy word for like precise and in-depth error messages that help you just debug a lot faster. So because of this, it's been used beyond just normal software development. I found that it's actually used in some type of academic research. Don't ask me what kind of academic research. I don't know, but that's what it says. Some type of Linux development, and apparently an Android native development kit, which is like Android with C. So that's Clang for you. She's a star. And the other compiler is the Swift compiler, which is also open source and also relies a lot on LLVM for quite a few things, for code generation and for some types of optimizations. It uses the LLVM universal IR as well. So they have that bit in common, Clang and Swift compiler. And you will often see this, like if you're looking through logs when you don't have anything better to do, or if you, I don't know, you just like looking at logs, who knows? You will see this as like it's written Swift C, like all together as one word. So that's it, that's what it means. And the front end of the Swift compiler is very involved with the work that we do day to day because it's involved with the, being integrated with Xcode. It's code completion and the syntax highlighting, which is like one of the features that I literally couldn't live without because one time my syntax highlighting wasn't working for some reason. I'm like, I'm gonna take a holiday because I cannot work without syntax highlighting. So this is who we have to thank for that. Not the dragon, just the compiler. And another cool thing about the Swift compiler is that compared to Clang, it has like an additional level of optimization where we are basically left with something called the SIL, the Swift Intermediate Language, which I think is really cool. So it's very optimized. It's very there's quite a few things I could say. I don't want to bore you too much, but it's I think it's pretty cool. And okay, so at this point, I was like, okay, I'm familiar with compilers, which I wasn't before, so that's a win. I'm familiar with what compilers Xcode comes with, another win. But like, what does this mean for me? At this point, after I kind of realized like how Xcode compile it, but from a superficial level, how Xcode compiles things and what Xcode comes with, I started to think about this, and I had like what I thought was a stroke of genius at the time. I was like, okay, so what if Swift Playgrounds only comes with the Swift compilers called Swift Playgrounds, not Clang Playgrounds? Maybe this is, it's just like something to make it lighter, to make the toolchain a bit more, I don't know, accessible. So this is an idea that popped into my head. And to be honest, like, I don't think it sounds too crazy compared to other crazy things I've said so far. Like, so I decided to look into this and try to figure out if there was any truth to this hypothesis. But the issue is, Xcode, if you look into the build report navigator, you can find so much stuff, I almost said a swear word, so much stuff about what's Xcode doing behind the scenes. But Swift Playgrounds doesn't have that. It doesn't show you what's happening, which is fine because it's not the point of this. Like, it's meant to be a more lightweight IDE. I doubt anyone that's learning or just having fun just wants to look at the build report navigator, so that's fair enough. But one cool thing that I discovered is that if you use Swift Playgrounds on the Mac, you can look into derived data and find the build logs from Playgrounds. And by the way, in derived data, which is something that I also found out as I was researching this and trying to understand what was going on, is not just like a folder that makes, like everyone loves to delete it, I love to delete it, and there's something in there. There's like actually a lot of important stuff in there, considering like including all types of build logs. Some of the build logs that we can find in derived data are these XC activity log format files that tell us like how long our builds are taking. And these activity log format files, they're like in like a weird binary format. So if you try and open them with a text edit, it'll just look like complete gibberish. But you can use a really cool tool that I wanted to shout out. It's called XC log parser. And this allows you to parse these logs into like JSON, HTML, like a bunch of different ways. And you can actually visualize like this, how fast these builds are taking, et cetera, et cetera. And I wanted to shout out because my team at Spotify actually worked on this tool. My old team worked on this tool. So yeah, now it's owned by the Mobile Native Foundation, and it's also open source. So if you want to look into it or contribute, it's out there. It's really cool. So I looked into the XC activity log files at first, but I couldn't find anything that was indicating like the steps of what is happening because they talk about something else. And I was like, okay, fair enough. But I looked around a little bit more because I was like, oh, actually, derived data has stuff. Interesting. So I stumbled upon this by complete randomness, just like looking into folders, looking into files, like I don't know what I was thinking, but I found these desk.xcbuild files that had all the build logs that I was looking after. And even though they are kind of like hard to read and understand, I tried to highlight them for you. And as I kind of scrolled and I looked for like the keywords that I was looking for, I found that my Swift Playground build logs had, first of all, a version of the Swift compiler, which is the same one that Xcode was using, and the same path to the same toolchain. So, okay, using the same Swift compiler version that Xcode was using, I was like, okay, that's fair enough, that makes sense. But also, as I went in further, you could also find that it has Clang. So I was like, I was both glad and annoyed because my hypothesis was disproved, which it has like a nice feeling to it. I felt like I was doing some science, but at the same time, I was frustrated because I said like, okay, what now? What is happening? There's got to be something else going on with Xcode that I'm not aware of, that I don't understand. And there's got to be some extra stuff that I missed. Sorry, little break for the water. Thanks, Tukina. Shout out to the water. Okay, so there's actually like a lot going on with Xcode. beyond just the compiler and what the compilers generally do. The first thing that I started to read into and I got familiar with is the Xcode build system. Xcode has its own default build system. It's called XeBuild, not Xcode build. If you try and look for XeBuild online, you will find most results about Xcode build. Xcode build is like a CLI tool. Most of you maybe have used it or come across it. That is very useful in like archiving your project, like doing things with projects and workspaces, but that's not what XeBuild is, completely different. But let's take a quick step back, actually, because I forgot something. What is a build system to begin with? So it sounds pretty normal, but what I read as I was like trying to research into this is like build systems are basically like a set of tools that coordinate and manage all the separate different tasks and processes that we need to get our code into an executable. So it's not actually involved in these tasks themselves, tasks being like compiling or linking or et cetera, et cetera. It's more like kind of orchestrating everything. At another conference, I gave a metaphor. I said like, it's kind of like Kris Jenner to the Kardashians, but not many people got that. So my alternative is like, it's kind of like your EM. The build system is your EM, and like all the different tasks are like the engineers. Like the EM is not actually, well, sometimes it should be, but not always doing all the coding. But it's more in charge of like organizing the whole jig. So yeah, so this is the XeBuild is the Xcode default build system. And I put new in inverted commas because there's like a newer version of the build system. Many of you probably saw in the build settings somewhere it says legacy build system, and you're like, what's up with that? In Xcode first 9 and then fully in Xcode 10, there was a newer version of the Xcode build system that was built in Swift. And the Swift version of XeBuild actually is what then enabled for SPM and other things to be going for. And it's built on top of something called LLBuild. So when I first saw this, I was like, this sounds like a little bit lower level. And it is indeed. Because LLBuild is, we keep going deeper and deeper, one level lower. LLBuild means low-level build system, but it's not quite. It's like a set of libraries that is used to build systems, so it's like the foundation of that. And it's also open source. Ta-da! You can have a look. It's really, really cool. Yeah, it's not just what is literally the foundation for XeBuild, but it's also the foundation for SPM. It's also used in Swift Playgrounds, according to the forum. So I was like, okay. And LLBuild made its initial debut at the cult meet at the conference for LLVM in 2016, not the cult meeting. LLVM, not a cult. Don't sue me, please. And the reason, so when it debuted in 2016, you can actually find the presentation. I think I linked it. It basically advocated itself to be like a more modern build system at the time that was following the LLVM philosophy, because as any organization, not cult, LLVM has like a philosophy for designing whatever is part of its technologies. And some of this philosophy is basically to use a more library-based design, more like API-like system rather than more CLI-based systems. So that's exactly what LLBuild is. And that's why it was really cool, and what it makes for something really robust, because if it's made in a library style, it can be co-designed with its component, and that's why it was paving the way for the other technologies that we used. But there's something cool that I was finding out as I was researching that I wanted to share with you, is also the fact that Apple is working like on and off on something also open source called LLBuild 2 that, it's still being worked on, but you can find it online. You can find the repo and the discussions around it. And it's quite cool, but we're going to touch on that a little bit later. Okay, so we've gone through a lot so far, and we have a lot more info about the Xcode build system. We know what's under the hood. We know what powers it. We know about LLBuild. And at this point, I was like, well, okay, what does it actually do in practice? Like, it doesn't just compile, right? There's got to be something else that's happening when you press build. And there is indeed. Because as I said, originally, the main goal of the Xcode build system is to orchestrate the execution of all these tasks that eventually will produce something that we can executable from our code. So this is kind of what happens on a very high level when we build a project in Xcode. And I thought it would be helpful to give a bird's eye view because it's very easy to get lost in the details, and we will get lost in the details, and we have gotten lost in the details. But this really helped me like figure out the grand scheme of things. I love saying that. I don't know why, the grand scheme of things. So we're starting with, once again, our source code from a high-level programming language. I wanted to add like a header, like an icon for header files or implementation files, but surprise, surprise, you can't find any in high resolution. So I just added the Swift, but imagine they're there. So what's happening is like these source code files are pre-processed. So that means like the comments are stripped, and in the Clang compiler, the preprocessor, which is like integrated in the compiler itself, actually like expands macros and does other things. I'm not too sure if this is also where the Swift macros are getting expanded, but that was my assumption. I still need to research that a little bit actually. But yeah, things are happening in the pre-processing stage to make the code a little bit more streamlined for compilation. And then what's happening is, like, as we talked about, the compilers take this, boom, 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 in a more scientific way, and output assembly code. Then the assembler, which is part of the compiler toolchain, takes this assembly code and it makes something called object files, which are like relocatable object files. They're not executable, but these object files are then like, they're usually, you will see them as a .o file. They're then like banged into with a linker together with any libraries that you need. The linker does stuff. Don't worry, like we'll know what does stuff mean. And then the linker gives us our final executable Mach-O file, which is then loaded into memory. But we're not going to talk about the loading into memory because that's like run a binary. And even though I did submit a proposal for that, we're only getting build a binary today. So maybe next year, maybe another time. So you'll be left with a bit of curiosity. Let's dive a little bit deeper into some of these steps, just because I think it's cool. We're going to take a little step back into compiler land because as I was starting to research this and I was like, okay, here's what's happening when you're pressing the build button. But I said, hang on, hold your horses, because when I'm writing code, I'm actually getting errors. Like I'm getting compilation errors as I'm writing code. So I don't actually need to press the build button all the time for that to happen. And that's true because the front end of the Swift compiler is actually active as you're writing the code. And I hope this diagram is like, I will go through this so it's maybe a bit easier to understand. But what's happening is like, you're happily writing your code is getting parsed, remember, parsed, split into token, arranged in the abstract syntax tree, and then analysis is happening. If any of this analysis like fails, you're getting your errors that are getting fed back to you, and then you're like, what's happening? Oh, semicolon. Well, no, actually, no semicolons. This is missing or that is missing. So you're fixing your errors and you're getting into that loop. So that's why you're getting it fed back as you're coding. There's other scenarios. For example, if you're starting a clean build, instead you're actually pressing the button and you're starting a clean build, what's happening is like some of the products from the front end of the compiler, like the AST, etc., are cached as they're being compiled as the front end is active. But when a clean build is started, the cache is actually cleared, and you have to do a full compilation from the start. That's why they take a lot longer than, let's say, an incremental build, which just uses the cache and then carries on building as normal. So I was like, okay, this is good, clearing it up. And sorry, I forgot I added this slide. I'll try and make it quick, because I also don't want to keep you here for way too long. So as this was happening, I was like, this is actually pretty complicated stuff. Like a lot more is happening than I'm just realizing as I'm writing code. Like this is active. There's so much. But I said, like, is LLBuild involved in any of this directly? And it turns out not quite, because we have something called the compiler driver, which is handling this. The compiler driver is like, and I hope I'm not butchering this metaphor, it's like a mini build system for the compiler only. So it's like the forums actually say, so I will read it precisely so don't make mistakes. The Swift compiler driver is a program that coordinates the compilation of Swift source code. So yeah, as I said, that's pretty much it. You can look at it. You can look at this as well because it is also open sourced as pretty much everything, and it's pretty cool. And what else is I going to say in this? Do you know what, folks? I'm gonna try and make this slide a little bit quicker because I'm afraid now that I am overcomplicating a few things. So I'll try and just say, pretty much the compiler driver has a bunch of inputs and arguments that are parsed in, like so in the parsing first stage of the compiler driver that handles things, you're selecting which toolchain you're gonna use, you're picking, which files to use, etc., etc. Then all these inputs are converted into a bunch of actions, which are then made into jobs and then executed. This is the briefest way I can put it. But it's really, really fascinating how it works. And once again, I could spend an entire hour just probably looking into this and talking about this. But I was like, okay, I didn't even know it existed before I started looking into this type of stuff. So I just thought, I was like, okay, it's cool to know like how much stuff is going on. And I'm pretty sure that they're working once again on a newer version also of the compiler driver. So that's pretty cool. It's pretty cool. Okay, so sorry for the rushing. This is all important to the compilation stage. And it's helping us get from, like our pre-processed code eventually to the assembly code. So what's happening after we get the assembly code? We get the assembler part, which is part of the compiler toolchain that basically takes this assembly code and outputs this like machine executable code into .o files that we just talked about. And yeah, these .o files are basically like non-executable Mac-O files, but we're going to talk about Mac-O files like in a second, so don't, yeah, I don't want to rush. So after we left these .o files, we're getting, as I mentioned earlier, into the linking stage. And I didn't know anything about linking. I know there's like some people at this conference that like, I don't know, just know the linker really well because they're C++ programmers and they instead are very involved with the linker, what the linker does. But I mean, I didn't even, like, I saw some linking problems at some point, but I didn't even know the linker really existed. Putting myself on the spot here. But it's actually really, really cool because if you look on the latest WWDC and the year before, they output some really cool videos about the innovations in the linkers and how it works. So I really recommend you watch them to get like a very deep understanding. But I'm going to give you like very quick rundown of what I understood from these videos. So as I said earlier, the linker takes your .o files and also whatever like libraries that you have, like static or dynamic, etc., etc. The libraries are handled a little bit differently, and I try to make a metaphor to understand it better myself. And hopefully it doesn't confuse you. Hopefully it also helps you understand. And the first one is like, okay, if we have a static library is actually like a bunch of .o files. Just that, which is fair enough. And I'm like, okay, so how do they interact with my O files at all? And the way that it happens is like the linker takes these .o files from the static library, and it's basically checking them against, checking all the symbols in these .o files against something called the symbols table. And in my metaphor, the symbols table is like a VIP list at a club. So please bear with me. What's going on is these files are basically like being looked at in a like a serial procedural order, so like one after the other. And we're checking the symbols. We're checking two things. We're checking for uses and we're checking for definitions. So if like I find a use for a symbol, I'm like penciling it in the VIP list. If I find the definition as well, I'm like, right, you're ready for the club. Please come into my executable. If you find the use, but you don't find the definition, you get the undefined symbol error, which I think maybe some of us have seen at some points. There was a bit of a problem with that at some point. And then if you find the definition, but you don't find a use, like you don't even want to go in the club, so there's no point including it, which I was like, okay, I get that now. And so that's what's happening with static libraries. With dynamic libraries instead, we actually have like a full-on executable Mach-O file. And we're still checking against the symbols table for uses and definition, but what's actually happening here, oh yeah, sorry, I forgot to say, very important. When in the static libraries we're in the club means that we're taking, what did I write exactly? Because I don't want to be imprecise with this. Well, we're basically like including it with our executable. Instead, with the dynamic libraries, we're still checking on the symbols table. And if it's in the club, we're not including it into our executable. We're just basically making a promise that like at runtime, we're going to take the path of this library and executing the symbol at runtime. I know you're hearing the clapping, which means the other talk is over, and you're probably jealous because you're still here. Sorry about that. I'll try and speed up. Another really cool thing about the linker, once again, do watch the dub videos from last year. They're really, really fun. They came out with a new linker, which is LD Prime. And that was like a big improvement in performance for a lot of people. For us, definitely, it was like really, really good. We benchmarked it, it was sick. And you could also backport it to Xcode 14, so that was cool. So what are we left with all this kerfuffle? Like we've gone through a lot of things, we've covered so many steps, and then we're left, as I said, with the binary, with the executable. But even when I started looking into this, I didn't even know what it was precisely. I had a pretty big misconception, which I thought that the IPA was the binary, but it's really not at all. So the way that you find it, if you want to look at where it is or what it is, you take the XC archive that you can archive your app, you get the XC archive. If you unzip that, you'll find a bunch of stuff inside, like the dynamic symbols. You'll find a special plist that has all this team and signing information. And you're also going to have a products folder. In the products folder, you have an app bundle, but that is not the binary. You unzip that as well, and you find a bunch more stuff, some cool stuff. Your plist is there, so don't put like anything important in your plist, because as you can see, like it's very easily accessible. But you'll find the binary itself, the universal fat binary. And when I'm calling it fat, I'm not being rude. Well, I could call it universal. That would be a bit more polite. But it's called that for a reason. And it's because this fat binary, like embeds different executables for different types of architectures. So we can imagine that like, it doesn't have to be two. I put two here because the latest Apple binary Apple Universal Binary is called Universal 2. As you can imagine, it includes both 64-bit Intel and Apple processors binaries. And that's pretty much it. Like a high-level overview of the fat universal Mach-O file is basically we have like these fat headers that are wrapping all the multiple Mach-O files that we have inside. And yeah, but what is a Mach-O file? The Mach-O file is the Mac object, is a file format that is native for macOS and iOS executables, so it's pretty special. And just a cool little bit of info for it is that it has like 3 main segments that are interesting to know. You've got like the headers, the load commands, and the segments. The load commands particularly, I found out that it's something that you can F around with if you are like evil, to basically like insert your own load commands. It's like essential to the linking stage basically, and you can, well, you shouldn't actually, that's illegal, but someone evil would. I'm digging a hole for myself. Anyways, I hope that now maybe you, if you didn't know before, now you can appreciate what I think is my best joke to date. Okay, so this is like pretty much an overview in depth, but also not in depth enough of the Xcode build system. And you might be thinking, I'm like, okay, is this the only thing that we have available? And the answer is that there's plenty of other build systems. And one of the build systems that we can actually use in Xcode that we do at Spotify is Bazel. Bazel. Bazel has a tagline because it's cool. It's called fast, correct, choose to, which I think is a bit cocky, but it does live up to this. And it's an open source build system, open sourced by Google. And it's based on their very powerful internal build system, which is called Blaze. And it's an artifact-based build system. More on that in a second. And the best thing about Bazel is that it shows some like very, very big improvements for multi-language and like very large code bases like the ones that we have. And it really speeds up build times. So it's pretty cool. Yeah, we use it at Spotify for a few things, quite a lot of things, but in the iOS world, we use it for generating the Xcode project because we are not crazy, we're not committing our project file. That would be, we have 200 almost 200 iOS developers and like millions of lines of code. It would be nuts to commit that. So we're not doing that. We're generating it every time we have to build it. And we use Bazel for that, specifically something called Rules Xcode project, which is really cool. And then we also use it for building the app and both locally and on CI. And the way you're like, well, how do you use Bazel? Like, you can't just say like, I'm going to use Bazel, and Xcode's going to be like, all right. But it kind of is like that. We basically have a setup that we have like we have a run script at the beginning of the build phase that when we are we're calling that, we're basically invoking Bazel to get everything done. That's the shortest way I could put it. But it's really cool. And Bazel is one of those things that it's really fascinating, but it's really complex to use, and you only really need to think about it or set it up if you really need it. But it is pretty interesting because I feel really bad, but I see the time. I'm going to have to skip this slide. If you want to know more about this, like, ask me later. But Bazel works in the way that, like, I have to explain this. No, I will summarize this. Pretty much, we're declaring what we want to build. Bazel takes all the snippets of stuff that we need to actually get it done. And then finally, in the execution phase, we get it done. And whatever Bazel makes for us is getting reused and it's getting cached. And that is part of what makes Bazel build so much faster. We have this like reusing mechanism, and we also are able to parallelize stuff. So it's a lot of strategies that it takes into account to help us build. And that is because it's an artifact-based build system, as I mentioned before, versus LLBuild is task-based. The main difference is that a task-based build system is very powerful because it's focusing on the how you want things built. But if you think about it, when you define how you want things built, it's very unreliable because you don't know how long that's going to take. It's not consistent. And that's why the build system really struggles to do things like parallelization and other more advanced techniques to make it faster because it is so unpredictable to do, even if it's very powerful. But they do say with great power comes great responsibilities. And the artifact-based build systems instead focus more on not how you want things built, but what you want built. That makes it a lot more consistent because you know exactly all the little bits that you need, and then the build system is taking care of the how. So you don't really have to worry about that, and that is what enables some of Bazel's coolest things. And you might be thinking now, you're like, Anna, but if artifact-based sounds so much better, why are Apple not using it? And I will tell you that, remember LLBuild 2? Actually, one of the cool things about it is that it's going to be more similar to Bazel with this because it's going to be artifact-based, and it's going to take. I think that's really cool. It's going to take into use things like reusing, like remote caches, like parallelization. So we're about to be, if everything goes right and they do continue working on this, we're about to have something on our hand that's like really, really fast. But that means that you can't use this excuse anymore, which is, I love that. I always used to say that. So yeah, we have gone through like a lot of stuff, and thank you for putting up with me and thank you for listening. But you might be thinking like, Anna, like we fell into like a million different rabbit holes. we, what happened to your playground failure? And I'll tell you, like, I still have this problem. Do you think I ended up figuring it out? Actually, I'm gonna pick. Do you think I figured it out? I really appreciate your trust in me. I really, really do. I haven't. It's still, I still haven't figured out exactly what's happening with it. But trust me when I say that I haven't given up. For now, it's still one of like Watch Mojo's top 10 iOS unsolved mysteries. This bane of my life. I have some hypotheses, but I think now I feel a lot more confident because all of a sudden I know it's not the compiler, nothing to do with the compiler, nothing to do with the linker because they're using the same one, nothing to do with the build system because it's the same build system as Xcode. But there's, like, as I said, a plethora of other things it could be. So my journey is about halfway there. And you're thinking like, no, Anna, please let us go. But this is like about all I'm going to explain for today. So in this journey, you might be thinking like, Anna, was this a major waste of time for you? I would say, in my opinion, it wasn't, because as I kind of followed this rabbit into like a bunch of rabbit holes, I've had a lot of fun. And I've increased my foundational knowledge of Xcode like quite a lot, because as I said, before I started this, I didn't even know what a compiler was, basically. And a good and also fatefully inconvenient habit that I got into is to start to always ask myself how and why are things. I stopped taking things at face value a lot, which is good and bad. Bad because it's now like very easy. I will just look at something for hours and hours and hours. But I find that is quite fun because it's made me, like, I don't know, a lot more confident when I'm working with Xcode, which, it's always good. And in this process, I was able to, like, this whole rabbit hole kerfuffle mess actually, like, really helped me discover so much about the joy and kind of the fun of exploration, and how fun it can sometimes be to just let your curiosity take over and see where you end up. And another quick rabbit hole that I fell into is that, weirdly enough, in psychology, there is a concept known as like different origin of curiosity. You can have something called the deprivation curiosity, or something called the interest-based curiosity. And the main difference between them, like, once again, I think I linked a psychological paper as well that I found because I found it quite cool, is the motivation of why you're curious about something. In the interest-based curiosity, it's mostly driven by like negatively perceived feelings, such as like, I need to know this or my boss is going to get pissed off, annoyed. I have FOMO, everyone knows this, I don't know this. While interest-based curiosity is more driven towards feeling of like, oh, that'd be fun. Oh, what is that? Oh, that's cool. And even though it sounds like a little bit simplistic, it's, it makes curiosity a lot more fun, I guess, because you're motivated by the pleasure and the joy of exploration and learning. And I think that this whole process helped me foster this kind of curiosity a lot more. Also, something cool that I read is that apparently the interest-based curiosity, if you're able to foster that, and psychological research says we should try and foster that, you have a lot of weird side effects. Like, apparently you are a lot better at general knowledge, so pub quizzes win. I did win a pub quiz recently, so maybe thanks to Xcode. And, and also you're better at spotting fake news, apparently, which is pretty cool. But this is one of my favorite quotes, I think, ever, by Albert Einstein. And it says, I have no special talent, I'm only passionately curious. And they do, by the way, they do say that Albert Einstein said a bunch of stuff that he never said, but this, I fact-checked this very carefully. 1952 letter to Carl Selig. So yeah, he said that. And I love this a lot because it's like one possibly of the smartest people of our like history said that his greatest talent isn't his literal genius, but his curiosity and how he relies on that. So I think it's very refreshing to see and to hear, and maybe it can encourage us, like iOS developers, to take a leaf out of his book and just indulge in our curiosity sometimes, and just let it run free and see where that takes us, because we can have a lot of fun in the way. Originally on my slides, I had like a really cute drawing of Albert Einstein, but Canva removed it for me for some reason. So I got ChatGPT to make like an AI version of what Albert Einstein would look like today. No, I'm joking. That is my dad. So he's also named Alberto, so almost Albert. Another quote by Albert Einstein that I wanted to leave you with, and I promise that's going to be it for me for today, is this beautiful, profound quote that he said. He really loved the linker. So thanks to Albert Einstein. And yeah, just wanted to say a quick thank you to all my colleagues and iOS friends that helped me rehearse for this talk. Thank you to Spotify and the DX team for putting up with me, for encouraging me and supporting me in all the learning that I've done so far. And yeah, thank you SwiftCraft and all the volunteers for organizing this amazing conference and for selecting the talk in the first place. And thanks to you for listening for so long. Yeah, thank you.